Okay, hi everyone. Today we're working on the Algebra 1 review for our final in about 1 week. So we have question number 1. I'm just going to go over question 1, 2, 3. I'm just going to go and see how many questions I can cover given the time we have left. If you have any questions for me or how I did a problem, go ahead and ask me, okay? So when we're solving for x, this is solve for x. So the goal, of course, is to solve for x, and we identify what x is. There's my x. And then the question has always been, how do we get x alone? How can this be x equals 2 by itself? See, this is a loner. He's alone. He wants to be in his room alone. We said we have to identify what numbers we have to get rid of. We have to get rid of a multiply 8 and a subtract 9. So we ask ourselves, we do opposite operations to do this. And opposite operations are, if it's plus, opposite of plus is minus, opposite of minus is plus, opposite of multiply is divide. So we also have to make a decision, do we get rid of the 8 first or the 9 first? And I gave you guys a little dumb story. You want to get rid of whoever's farthest away. 8 is literally hugging you. So let's get rid of the 9, it's farther away, so we're going to plus 9 to both sides. When we subtract it, we see 8 x is equal to negative 73 plus 9 is 64, negative 64. Now it's cleaner. See how there's less stuff there? It's like we're cleaning our room. We got to get rid of the 8. Opposite multiply 8 is divide by 8 to both sides. So if you look at all the work I'm showing, this is my expectation for you guys when you guys are showing work. Okay. If you're not showing work, I know you're probably using some assistance someplace. Now, if you need extra help, all these questions have videos next to it or some type of website that you can refer back to. You can also click similar question, which is kind of cool for the site. You can always just say, hey, I want to do another question just like this. So you can hit similar question and allow you to do that. Okay, let's go and take a look at our next problem. And these problems are the problems that will be similar to that on your final, okay? Same style, numbers will just change. So make sure you do practice this. Now, these are going to get progressively harder step by step. Now, we don't like fractions, that's why I put this as question number 2 instead of question number 1, even though there's less steps. Now, how do I solve for n here? Well, we have to get rid of the 6. And what's the 6 doing to the n? Dividing. And the opposite of dividing, we always use opposite operations for us to move stuff across the equal sign, kicking stuff out, opposite operations. So the opposite of divide is multiply. So we're going to multiply by 6 to both sides. And 6 divided by 6 become 1. That's why it cancels out. And 9 times 6 is 54. Okay, so we would just write 54 in the box. On the right side, you can see that there are 9 different types of problems, and you can have 8 tries to solve this out. That's what those little symbols mean. Okay. All right, let's go take a look at our next problem. Solve the equation. So instead of having one fraction, just a 6, I have a 9 and a 2. So we have a special way of solving this, is we're going to get rid of 2 moves at once. We're going to get rid of a divide, and we're going to get rid of a multiply. So we have a special way of doing this, is what we say we multiply by the reciprocal. And the reciprocal of 9 over 2 is 2 over 9. 2 over 9. When I multiply by 2 over 9 to both sides, to be fair, okay, the 9's divide out and the 2's divide out. On the right side, we can multiply 18 times 2, but let's save ourselves some time because I can divide 18 and 9. What's 18 divided by 9? Or another way of thinking about it, how many times does 9 go into 18? That's twice. 2 times, oops. So x equals 2. These divide out, leaving me a 2. 2 times 2 is equal to 4. If you want to practice that again, hit similar question and you can do it again. Okay, this next question is, again, 2 steps practicing if I'm solving for x. What numbers do we have to get rid of? We have to kick out the 8, negative 8, and the minus 5. So we talk about which one do we get rid of first. We get rid of what's really close or what's farther. And we describe that as we're going to get rid of what's farthest away. So let's get rid of the 5 first before we worry about anything else. Add 5 to both sides. X over negative 8 is equal to 8 plus 5 is 13. And then we still have to get rid of that negative 8. Negative 8 is dividing, so we're going to multiply both sides. Then we multiply both sides by negative 8, because the opposite of divide is multiply. And x equals to, this is 80 plus 24, that's 104. Okay. 8 times 10 is 80, and 8 times 3 is 24. That's why it's 104. And don't forget the negative sign. It is negative. Positive times negative is negative. For my version, of course. Okay. Then question number 5 looks a little bit wordy, but that's why we want to practice it so we know what that looks like. A lot of people do well on SAT, not because they're geniuses, because they practice the test already. So when they see it, they know what they're asking for, even without reading the directions. Solve the equation for the given variable. If your answer is a fraction, write it in reduced fractional form. Do not convert your answer to decimal, okay? Do not convert your answer to decimal. Now, a lot of people had these problems when we first started. And the idea is that first we want to get rid of the parentheses. By distribution, we're going to distribute the 4, we're going to distribute the 5 through multiplication. And then the problem will look a lot easier. Oops, it says interval notation. Darn it, I was hoping I had not done any of those. Michelle, which question was interval notation? Probably forgot how to do absolute values. So question number 7 is absolute values. And the trick was, do you see these walls here? We can't do any math with these walls. So we said we trade absolute value signs for a plus and minus. So we trade x minus 3 equals to 9 and x minus 3 equals to negative 9. And we make the sign on the outside flip from positive to negative. Okay. So we give ourselves 2 different options, and then we can solve these separately. Plus 3, plus 3, plus 3, plus 3. The cool thing is that these 2 different options, they're just twins, the mirror images of each other. So what we do for one, we do for the other. That's 12. And x is equal to negative 6. Now, is this true? Would 12 and negative 6 be a solution that would give us 9? Well, just to double check, absolute value of 12 minus 3 is absolute value of 9, right? And the absolute value of 9 is 9. Yeah, that's a win. And on the other side, I would never have thought about this negative 6 as an answer. Negative 6 minus 3 is negative 9. Hey, an absolute value makes everything positive. That's going to be a positive 9. Okay, good question. So I got distracted for this last problem. So let's go ahead and distribute. We 12x plus 12 is equal to 20x plus 20. And then now we have to combine like terms, a skill to say, hey, well, let's move all the x's together. Now the question is, do you want to move the 20 to the left or move the 12 to the right? And in my example, I always like to say, hey, imagine if this was a party on the right and party on the left. Do you want to come to my party where there's more people, or you want me to go to your party with less people? And of course, we want to go to the more party side. And the reason why we do this is because when I move it over, take a look. 20 minus 12 is going to be a positive number. If I moved it over the other way, we would end up with a negative 8. And I prefer positive numbers over negative numbers. This 12 hasn't changed, as well as the 20. These are just coming down. Now, we want to solve for x, so we get rid of the 20 first. And then we'll get rid of the 8 next. Opposite of multiplication is division, so we're going to divide 8 to both sides. So x is equal to negative 1. Yeah, so Cleona, I changed for number 8, so you don't have to answer number 8. It should have said your teacher has taken the question away. What it means, though, just so you know, it's a different way of answering a inequality problem. So if you take a look here, once you solve it, the inequality should end up with this answer here, a and problem. So instead of writing all this notation, and math people don't like wasting time, so they came up with an interval notation. So they, instead of using a inequality, they just use parentheses or brackets. So if it's less than, they use parentheses, and we say, hey, we can go from negative 2 all the way to negative 1. That's what this means. On this, if it's an equal sign, see how these are equal? Instead of using parentheses, they use brackets. And bracket means we're going to include, it's a hard cap. We're going to include the negative 2 and negative 1. That's what interval notation is. Michelle, let me go take a look at number 13. So number 13, you're going to write out the interval. So you're going to say, did I say interval notation again? Oh my goodness. Oh, they did do interval notation. So this would have been 3 is less than x less than 4, okay? But so interval notation would use parentheses instead. And we would say parentheses 3, comma 4, close parentheses. And this means answers from 3 to 4 would all be okay. So instead of writing it with inequalities, we can write it with parentheses. And mathematically it's the same, but I feel it might be easier to write and easier to look at sometimes, depending on the person. So darn it, this interval notation is messing me up. Okay, here's jumping to number 12. Same idea here, except this is a compound inequality. So we see that there's 2 inequalities here, and we're still solving for x. Now for this problem, I'm going to rewrite it to give myself a little bit more space. It's actually a pretty easy problem. We just have to remember how to do it. And my joke was that you would just cover up one side. If I just cover this up, isn't this just like a regular problem? Or if you want, you can cover up the right side, and that would be like a regular problem. But for both of these problems, what number do you get rid of first, the 3 or the 8? We would get rid of the 8. So we do the same move to both sides at the same time. So if I add 8 to one side, I want to add 8 to both sides. So it's almost like I'm juggling 2 conversations at once, but I'm saying the same thing to both sides. After I do this, we end up with 6. Oops, that's 6 less than 3x less than equal to 13. Okay, from here we're still going to get rid of the 3. Then we're going to divide both sides. Go ahead and divide 3 to both sides. That's going to be 2 less than x less than equal to 13 over 3. And the right side is a fraction, it looks like. But that's okay. So we just enter our answers there. 2 is less than x, which is less than equal to 13 over 3. Okay, so let's jump to 15. Solve and graph, okay? So the question looks super confusing, but they just want us to solve for them separately. 14x minus 2 less than 5x plus 20, and we're going to graph them on one graph. And we're going to graph we're going to solve the second one. Let's go ahead and solve the first one. First, I'll move the 5 over, minus 5x to both sides. 9x minus 2 is less than 20. Then we're going to plus 2 to both sides, plus 2. Plus 2 to both sides, and then we end up with 9x is less than 18. Oh, sorry, plus, oops. Oh, sorry, I mean, that's a plus, that's a minus. I messed up copying it, I'm sorry. That becomes 18, and then divide both sides by 9. X is less than 2. Okay, so first thing we're going to graph, x is less than 2, so x is less than 2, so for sure we're going to go that way. That's our idea. And our next part is, let's go solve the second equation, negative 9 plus 3x less than 9x minus 3. So I'm going to move the x over, so minus 3 to both sides. Negative 9 less than 6x minus 3, then plus 3 to both sides. X, oh, this becomes a negative 6, is less than 6x, so divide both sides by 6. X is less than negative 1. Wait, did I make a mistake someplace? Less than or equal to? Okay, so x is greater than negative 1. So here's negative 1, we'll be solid. X is greater than. So we're stuck between our hollow at 2 and solid at negative 1. And so that's how we're going to graph it. So you're going to put a hollow and solid dot on solid on negative 1 and hollow on 2, and then you're going to draw a line in between. Let's see what that looks like. So here is 15. I'm going to put a solid dot on -1, a hollow dot on 1, was it? And then we'll draw a line in between. Let's go. Got fractions on one of them. I wonder if I can change the dot to a fraction. It can do halves. Can you tell me what your question was, perhaps? Maybe we can check the math real quick. If it's a fraction like a half, you can graph halves on there. Okay, -10. So this is -11 plus 4x greater than or equal to 13x minus 2. Let me double check that. -11 plus 4x greater than 13x minus 2. Sure. And then I'm going to minus 4x to both sides. Remember, -11 is greater than or equal to -13 is negative, so positive 9x minus 2. We're going to add 2 to both sides. And then we end up with -9 greater than 9x. When we divide both by 9, that gives us x is greater than -1. So I think you probably messed up on maybe copying the sign. Maybe over here. Gave you a fraction. Oh, okay, yeah. If you did that, you probably would have ended up with a negative 9x, which has been fine. Okay, I'm going to go ahead and do the last. Last one is very similar to the one we just did. To solve it, 13x plus 5 greater than 6x plus 26. And when we solve it, minus 6x to both sides. We're left with 7x plus 5 greater than 26 minus 5 minus 5. We're at 7x greater than 21. Divide by 7, divide by 7. X is greater than 3. So here's 3. This is hollow and x is greater than 3, so draw an arrow to the right. And our next problem is -4 plus 8x greater than or equal to 11x minus 1. Minus 8x to both sides. -4 is greater than 11 minus 8 is 3x minus 1. And then plus 1 plus 1, we're at -3 is greater than or equal to 3x divided by 3, divide by 3. X, sorry, I'm going to squeeze this in here. X is greater than or equal to -1. So at -1, we say x is, oh wait, x is on the less than side. So we're actually going to the left here, because x is less than it.